So our topic is vector addition. Okay, so vector addition. Now if you have two vectors, for example vector A, let's say this is a displacement vector A, then vector B. Okay, this one from the start to end we call that sum vector. The notation is let's make it C. Again, this one, the C is A, we call that vector sum, or widely known as resultant. Okay, now in mathematical equation, this is vector C, the sum vector, equals A plus vector B. Take note, they are not algebraic sum. So if this is 5, this is 3, it's not 8. Okay, now we could also say that this is B, vector B, then this is vector A. This sum vector is the same as this one. Okay, they are just the same. Now with that, we could say that C equals B plus vector A, or A plus B equals B plus A. So even though it is reverse, they have the same value. Now let's proceed in 3 ways to add two vectors. Okay, so with that, now two vectors, for example vector A, it's 5 meters 30 degrees north of east, and vector B, let's say 3 meters 3 meters, let's see, vector B 3 meters to the east, so it's just a horizontal line to the east. First, we will use the graphical method. Okay, this is not the way, but I mean we will use graphical method then analytical method, but I will show you 3 ways to add vectors first. Now the first one, A, is what we call head to tail. Now graphical method, you should have a ruler, okay, and you should have a scale in the sense that this is meters, so I would say that in 1 meter, that is equivalent to, in my paper, let's do 1 cm. Okay, so that's my scale. Now I would draw a Cartesian plane, okay, and this one, X and Y. Then A, it's 5 meters 30 north of east. So north of east, this is east. The north is going up. So I will use a protractor. Okay. I hope you could see. I will use a protractor. Then I will locate the 30 degrees, and the 30 degrees is here. Okay. So 30 degrees. Okay. Then I will count or measure 5 cm, because this is 5 meters, and 5 meters on the paper is equivalent to 5 cm. 1, 2, 3, 4, 5 cm. Okay? So until this one. Now, this is the vector A. Now, for the vector B, in the tail, or the head rather, so we'll create another Cartesian plane, something like that. Then for B, this is going to the east, or so it's going to the right. Then I will measure 3 cm, because this is 3 meters. So until this point. Okay. This is B. Okay, vector B. Then to find the displacement similar to this C, I will just connect the tail or the end to the start. So this is the C. So again, this is A. Okay, this is A. That's the head. And the other one is vector B. Okay. So this is vector B. That is vector A. And this one is vector C. In terms of graphical, I will just measure from here to there, and my measurement tells me that it's about 7.5 to 8 cm. So let's call this 7.8 cm. So this one would be 7.8 cm. So to translate that here, that is 7.8 meters. And how many degrees? So I will just get my compass, then measure it. Of course, this is not accurate anymore. So approximately 20 or about 19 or 18 to 20. So 18 to 20, let's make that 19. So that is 19. This is 19 degrees. So 19 degrees north of east. So that's my vector C. Okay, using graphical method by using ruler, protractor, and plotting it in the paper. So this is important so that you could visualize. Later on, you will not use graphical method anymore. But you must practice graphical method so that you will understand fully the concept. Okay. Now, that is A. We have two more left method. The other method is reverse, meaning it's also head to tail, but in this case, I will be first plotting vector B. Okay. So vector B, it's to the east, and that is 3 meters. In my paper, it's 3 cm. Okay, it is here. This is B. Again, at A, we first plot A. The second, we plot B. So I will create another Cartesian plane here. Okay. and 30 degrees. So the one, then I will measure 5 cm, so approximately here. Then here's the vector C, and this is A rather. So this is A, okay, and the green one is B, that. Then the red one is C. Of course, this is not very accurate because we have a problem with something like that. Then we will measure it approximately 7.5 to 8, same to this one, and I guess this is now 7.8. Okay, so that is, the C is 7.8 meters. Then if you measure the angle, of course, here is the angle here. If you measure it, it will become, so that is around 19, so 18 to 20. So I hope you can see that. Oops, sorry, I didn't see the video. So again, I plotted, sorry, you didn't see the video. I plotted the A, then B. Okay, oh no, B first, then A. In this one, it's A, B. Now, as you can see, they have the same sum vector. Okay, so, and I measured the angle. Of course, they should be the same. And this one is around 18 to 20. Later on, we will do the analytical method so that you will appreciate the accuracy of analytical method. Now we have, of course, I'm discussing 3 methods or 3 ways. So we have A, 1, 2, and the next one. The next one is C. Malit pala ang aking screen. So, nasan tayo? C. Okay. C. Using for C, we will be using wait. Parallelogram. Parallelogram. What's that mean? So, again, instead of head to tail or head to tail, this one is also head to tail. We will not be using that one, but this one. So, Cartesian. Then you can begin with A. The A is, of course, 30. So, here's 30 degrees. Like that. Okay, and then 5. Okay, this is A. So 30 degrees. Then the other one, instead of putting it here, I'll put it in the tail. And that is 30. Like that. So I have the A. Here's the A. Okay. And the other one is B. Here. Okay. Now, what's parallelogram method? I will create a parallel line. From this point, I will create a parallel line of A. So, this one, parallel line like that. So this one is parallel to A, and I will create, this is B, I will create a parallel line to B. Okay, so I call parallelogram. Then you have the parallelogram. So this is parallel to B. Okay. Then the other one is parallel to A. Then from here, the tail to this point, I will connect. Then you will have C. Actually, they are the same. Here is the one, and they're same. If you measure it, guess what? It's 7.8. Or of course, in this case, it's almost 8, but it's between 7.5 to 8 cm. And if you measure, it should be 18 to 20 degrees. Okay? See? Here is 20 because it's too thick. So if you use the AutoCAD, you'll make it as 18 or 17 point something. So that's the 3 ways on how to solve 2. Take note 2. Later on, we will be dealing with multiple. So that's another venue or another method. But first, you have to learn the graphical method so that you will understand fully. Okay. Now, speaking of another method, okay, that is the analytical. Okay. By the way, take note that the first video that I uploaded, the so, ka, towa, this one is not applicable to this when you're solving it, because this is applicable to right triangle. Right triangle is this one. It has 90 degrees. So you cannot, okay, you cannot use this one here because this is not right triangle anymore. And what to use? You will use the sine and cosine law. Okay. So now let's solve this one analytically using sine cosine law. First, you have to take note that we are dealing with this rectangle, the black one. And now, the black one, forget about the blue and the dotted or the broken line. So what is given? Of course, this is C. And the magnitude A, the magnitude of vector A is the same as here. So let's call this A. And of course, this is B, magnitude B. Magnitude A is, that is 5. A. Then magnitude B is 3. And this one is 30 degrees. Okay. 30 degrees, so it means this is, so that is 180. From here to there, 180 minus 30, that is 150 degrees. So you have here a triangle like that. Oh, mas maganda yun. Diyan na lang pala. Para hopefully kita. Okay. Now, I want to find C. To find C, since you're given with this one, the sides. By the way, what is sine law? What is cosine law? Cosine law. Okay. Cosine law. Here's the cosine law. C a squared plus b squared minus 2ab cosine cosine c. Okay, cosine c square root. So that is cosine law. Let me put it here. Then that's cosine law. Okay. Now, you're finding the c, the magnitude. And to find it, we will use cosine law because you have, here's the c, you're given with a, you have b, then you have, of course, cosine c, or c, the c is an angle opposite to c, and that is 150. So, we just put it there. I mean, c now, it's square root of, you have a it's, what's a again? That is 5 squared plus 3 squared minus 2 times 5 times 3 cosine 150. By the way, you must make sure that your calculator is set into degrees, not into radians. Then you will find out, if you calculate it, if you have your calculator, you will find out that this is 7.7447 meters. Okay? 4 decimal places in our class. But again, in terms of significant figure, masyadong hindi na significant yung 4 decimal places. But for our class, our discussion, let's make it 4 decimal places. Okay, I hope this one I understand. Now take note, if you go back, this is 7.8. We measured 7.8. And our calculation 7.74. And they are close. Okay? Because of the limitation of the ruler. So, that is how to solve analytically. And this one is our solution in your quiz. Of course, the graphical method, you can use that one to check your analytical method. Now, how about the degrees? This one. Last time we measured it in between 18 to 20 degrees. So, how to solve? You can use the cosine law, but I would prepare here, in this case, the sine law. Okay, I think this is my favorite. Why? Because it's very easy to memorize. You have sine A, that is A, then sine B, and this is B, sine C, this is C. Okay, we're finding for this one, and that one is the opposite of A. So this is big A, I mean angle A, so we need this equation. Of course, you have this one. Then what else? You're given with this 150. You don't have the angle here. You can compute, but I think it's very easy if we have, because this is given, that is 150, and this is solved. So, we'll be using sine A over A equals sine C over C. Okay? Sine A is now A over C sine C. So, A, what is A again? That is 5 over C, that is 7.7447 sine 150. Okay? Sine A. A, or angle A now, is inverse sine 7.7447 sine 150. Should be in degrees. Your calculator should be in degrees. And I computed that. Oh wait, sorry, is that A? I think, tama ba? Parang mali Is this A? Tama. That is A. So, please compute. I think this is 57150 and this is 18.8323. So in our graphical method, again, we measured it in between 18 to 20 degrees. In our analytical, it shows that they are correct. So that's it for the adding vector. So again, vector addition. So 3 ways in vector addition. Okay, you have head to tail, the reverse one, parallelogram method. Then I showed you how to compute it by using graphical method so that you will visualize, and analytical method so that it is more accurate. Okay, see you next video.